Here's the next question, number 40. An 8-bit unipolar successive approximation register type ADC is used to convert 3.5 volts to digital equivalent output. The reference voltage is plus 5 volts. The output of the ADC at the end of the third clock pulse after the start of conversion is, well, we have our options, 4 options, and they are all 8-bit. So let's first write down in general what's given to us. So we have been given, then this is an 8-bit successive approximation register, and we have also been given that the reference voltage is plus 5 volts. Now since the reference voltage is given to us, we can calculate what the resolution is. The resolution is K, which is V reference divided by 2 power n. That's 5 divided by 2 power 8, which comes around to 0.0195. Now we have also been given the applied input 0.5 volts. Applied input voltage is 3.5 volts. So when we're talking about successive approximation ADC, we should know that it always starts working from MSB. So from after the first clock pulse, so we are going to calculate and write down what happens at every clock pulse. So the first part is after the first clock pulse. So after 1 clock, what happens is that the SCR will toggle its MSB from 0 to 1. So it will toggle its MSB from 0 to 1. So the output of the SAR would be, now remember this is an 8-bit, so it would be 1 0 0 0 0 0 0 0. So that's 8-bit output. So this is what we get after the first clock pulse. Now the next is after the second clock. Now after the second clock, again the SAR will toggle its 7th bit this time from 0 to 1. 7th bit from 0 to 1. So the output becomes 1 1 because it's the 7th bit, 0 0 0 0 0 0. Now this output, it results in a value that is greater than 3.5, which is the input, applied input. Now it should not be greater than 3.5. Since this value results in a value that is greater than 3.5, the output of the second clock will be the same as that of the first clock. So this one goes back to 1 0 0 0 0 0 0 0. I hope this makes sense. Now once this is done, we go for the third clock. So let's see what happens at the third clock. At the third clock pulse. Okay, so now the output from the previous clock pulse is 1 0 0 0 0 0 0 0. So at the third clock pulse, this time the SAR will toggle the 6th bit. Sixth bit. What's the 6th bit here? This one here. So it will toggle from 0 to 1. So it becomes 1 0 1 0, 0, 0, 0, another 0 there. So this is the output of the SAR after the third clock pulse. So this matches option A. Well, this is the solution and I hope it has helped.